As we continue to look at standard form, we will be working questions that contain negative powers of 10. Before we do so, let's quickly review what we did in the previous video. In 4,543,000, in order to write it in standard form, we must first identify the position of the decimal point. Since it is a whole number, the decimal point would be to the right of the last digit, which in this case is 0. The second thing we need to do is to move the 0 in the appropriate direction to get only one unit remaining to the left of the decimal point. In this case, the direction we must move the decimal point is to the left. So we will move the decimal point to the left. 1, 2, 3, 4, 5, 6 times to the left. So in standard form, 4,543,000 will be 4.543 0.000 times 10 to the 6th power. Now, I want to point out to us that the zeros in this case have no value. So this number can be written as 4.543 times 10 to the 6th power. So once the zeros are to the right and are not to the right of the decimal point or to the end of the decimal point, and they are not in between any other non-zero numbers, then they have no value. In our second example, we have 7,800,000 to be written in standard form. Again, we must identify the position of the decimal point, which in this case is to the right of the last digit, which is 0. And we will count the number of places that the decimal point needs to be moved. So we'll count 1, 2, 3, 4, 5, 6. Our answer will become 7.8 0 0 0 0 0 and 0, and this will be times 10 to the 6th power because we moved the decimal point 6 times. And again, we can eliminate all these zeros that are to the right of the decimal point to get our answer to be 7. That's our 7.8 times 10 to the 6th power. Our third example is 0.00968 to be written in standard form. Since this number is already a decimal, we already know the position of the decimal point. So now we need to figure out what direction to move the decimal point in. As you notice, the only digit to the left of the decimal point is a 0. And our aim is to get only one digit to the left of the decimal point but that digit cannot be 0. So we want to get one non-zero digit to the left of the decimal point. In order to do so, we must move the decimal point to the right until we have achieved that objective. So we move the decimal point 1, 2, 3 places to the right. So our answer will be my apologies. So that would give us 0 point, oh, no, not 0 point, 0, 0, 0 point, come on, not point again. It would be 0, 0, 0, 9.68. Or again, since the zeros are to the left of the first digit that has value, then you know the zeros are really placeholders, so it can be written as 9.68, and that would be times, all right, let me take this here and put it, oh, take it from here. So it would be 0.68 times 10 to the negative third power, or 9.68 times 10 to the negative third power. Now, you might be wondering, why is the power negative? I want to draw your attention to the fact that in our first two examples, we were moving the decimal point to the right. Hence, the powers were positive. But in this case, we are doing the opposite of moving to the right, which is moving to the left. So hence, the power of the index value will be negative. Here's a question you can try doing before you actually watch me work the solution. It's 0.0000543, and we want to write it in standard form. Okay, so what you should have done is you should have moved the decimal point to the right 1, 2, 3, 4, 5 places. So your answer would become 0, 0, 0, 0, 0, 5.43. And remember, it's not the same if we don't multiply it by the power of 10. In this case, we move the point 1, 2, 3, 4, 5 times. So it would be 10 to the negative fifth power because we move the decimal point to the right. Or it can be written as 5.43 times 10 to the negative fifth power. So there you have it. We have learned how to write numbers, ordinary numbers, in standard form using negative powers of 10. See you next time.